Hello, in this video we discuss about the conceptual understanding of friction. What is friction? Before going to the what is friction, let me tell you a few examples on it. Every day we do so many activities like we hold a pen, we hold a pencil, we hold a marker and write on the board. When you want to throw a ball, you need to hold the ball with the grip and you need to throw. When you want to run on the ground or on the road, you should have perfect stability while you're running. And when you're sitting on the chair, you should feel that you stably sat on the chair. So how all these things are possible is only due to friction. Friction helps you to hold the pen, hold the marker. Friction helps you to walk on the road, run on the road. It also helps you to sit stably on the chair. So without friction, you cannot imagine the world around you and the activities what are doing in your life. So let us discuss more about friction. Okay, what is friction? So the definition says it is a resistive force or opposing force to the relative motion of a body. Resistive opposing is nothing but opposing the motion. And here I mentioned relative motion. What is this relative motion means? So this relative motion means the body either at rest, the body either in motion. That is what called relative motion. So friction, it opposes the motion of the body. Friction opposes state of rest also. That means if the body is at rest, it helps the body comes into motion. If body is in motion, it helps the body to comes to rest. Both the ways are possible. Let me explain more about this. Now see here, this is a simulation. There is a box on the road and I am applying the force, going to apply the force gradually. So that means now when I apply the force increased to 200 Newton, where the frictional force is 125 Newton, the body started its motion because the resultant force, if you see the resultant force towards right side. So more force towards right side, the body is in motion towards right side. That's okay. Now the body is in motion. Now if I stop applying the force, now see what happens. You can see the more frictional force and the body gradually comes to stop. And it is happened because of the frictional force between the box and the ground. So in this way, when the body is in motion, it comes to rest because of the frictional force. Now see this diagram. There are two surfaces, ice surface, road surface. So a person wants to walk on the ice surface. Similarly, the other person wants to walk on the road. In which case, you feel that the person walks comfortably. Obviously, it is the road surface. Why? Not on the ice surface. Because ice surface is wet surface and then the wet surface reduces the friction. And when the friction is reduced, the person unable to walk on the ice surface, he slips and falls on the ground. But on the road surface, it's a different case. The surface is not slippery. The road surface gives a grip on each and every step on the walking, in the walking, so that the person easily walk on the road surface. And so this example tells you that friction supports the motion of the body. So we understand that friction opposes the relative motion, means the body which is at rest comes into motion, the body which is in motion comes to rest. Okay, one important thing, friction is a contact force also. That means friction you cannot experience, friction you cannot see if the two bodies are not in contact. So it's very, very important that the two bodies are in contact. In the previous simulations also, if you observe, the box is on the road. That means the box bottom surface and the road top surface are in contact. and that is the reason why there is a frictional force acting on the body. Okay, the point is that, okay, friction is a contact force, but how it opposes the motion of the body? It is because all surfaces, if you see in our real life, if you see the glass surface, if you see the wooden surface, we feel that all are smooth, but actually those are not smooth. Microscopically, those surfaces are rough, or in another way we can say the surfaces are uneven surfaces, and frictional force is generated due to uneven surfaces of the contacting bodies. If the uneven surfaces are high enough, then the frictional force is also high. If the uneven surface is low, then the frictional force is also less. So let me explain you more about this. See the simulation. Here there is a chemistry book on the physics book. That means chemistry bottom surface, physics top surface, both are in contact. So when they are in contact, obviously there is a frictional force. So this is what we see here. But microscopically, if you magnify them, you can see the atoms of the chemistry book and atoms of the physics book. There is a thermometer. Now see what happens. So when I move the chemistry book, you can see the molecules of chemistry also moving. But if I move little vigorously, then what is happening to the thermometer? The thermometer shows the level in the red color. That is nothing but temperature increases. See, the molecules or the atom starts vibrating and the temperature increases. So friction between the contacting surfaces is generated, and also says that due to friction heat is generated. So this simulation is explaining you very clearly that friction generating heat. At the same time, it says that macroscopically we have contacting with the molecules, and because of that friction is generated. So the previous simulation gives clear idea that even the surfaces are very smooth, still they are not smooth macroscopically. They are uneven and they are rough. And because the uneven surfaces, friction is generated. At the same time, we can also understand that friction generates heat also. One simple example: if you rub the two palms of your hand together for a short period of time, you feel that the heat is generated. So that simple demonstration says friction generates heat. Now see, types of friction. There are two types of friction: static friction, dynamic friction. What is static friction? Static friction is a friction opposes the just started motion. What it means by just started motion? Let me explain you more in detail. See here, there is a simulation again. A box on the surface, and if you see, now I am applying the force, applied force 17 Newton. See the simulation there, applied force 17 Newton. Now the applied force is 27 Newton. Now see the frictional force, again 27 Newton. If I increase the force to 44, frictional force is also 44 Newton. If I increase the force to 48, frictional force is also 48 Newton. So what is happening here? So frictional force between the box and the road gradually or proportionally increasing with the applied force. But this won't be the case for the long time. Keep on increasing. When the applied force come to a point where it is 140, say, applied force, the body started moving. So as soon as the body started moving, the frictional force what is appeared there is what called static friction. So static friction is the opposing force to the just started motion, and here the body just started with the force of 143 applied force, and the frictional force what appears there is 125 Newton. So once again the definition, it is the opposing force to just started motion. So see the diagram here below the static friction. There is a box on the surface. This box is experiencing three types of forces. One is applied force F, normal force in the upward direction. As the body is moving right side, there is a frictional force opposite to the right side direction, which is left side, and this frictional force is static friction. Just a static motion opposing it, it opposes. Now, the law says frictional force always directly proportional to normal force. More the normal, more the friction. How we can say these are directly proportional? Let me explain you in detail. Again, see this box on the road. Now, when I apply the force of 50 Newton or 100 Newton, now the applied force is 150 Newton, the frictional force is 125 Newton, the body is moving in the right side direction. Now I increase the weight. When I increase the weight, what happened to the frictional force? Frictional force is also increased. If you observe carefully, right? Frictional force is also increased. Previously it was 150 Newton, now it is 250 Newton. Why? Because more the weight, more the friction. In other words, I can say more the normal force, more the friction. Hence we understand that frictional force is directly proportional to the normal force, because as you know, normal force is exactly equal to the weight of the body. So more the weight, more the normal force, and more the weight, more the friction. Therefore friction is directly proportional to normal force. So static friction is directly proportional to normal force. To remove the proportionality, we use a constant called mu s. This mu s is called coefficient of static friction. So therefore Fs equals to mu s n is the formula for static friction. If you want to calculate static friction, this formula to use. Fs equal to mu s n. Fs is static friction, mu s is coefficient of static friction, n is the normal force. This is what static friction. Now coming to dynamic friction. Dynamic friction is defined as it is the friction when the body is in motion. It is a friction when the body is in motion. As I said, it is only visible when the body is in motion, and so this friction is always lesser than the static friction. Why? Because when the body is already in motion, the frictional force what you see is very less. If the frictional force is more, then you don't say that the body is moving at high speed. If the bodies are moving at high speed on the roads, still you have friction, but the friction is very less comparing to static friction. So that's why if Fd is the dynamic friction, then Fd is dynamic friction and Fs is static friction, always Fs is greater than Fd. That is, static friction is more than dynamic friction. Now see here, the same diagram like static friction, the applied force is towards right side, so friction is left side, and it is here also dynamic friction is directly proportional to normal. Therefore, if you remove the proportionality, you will get constant mu d. Mu d is called coefficient of dynamic friction. So Fd equal to mu d n. So both formulas format is same. Static friction mu s n, dynamic friction mu d n. Only the difference is the type. It is static, that is dynamic. Now the problem solving skills in friction. See the first problem. A block just started its motion by an external force on a surface with the coefficient of static friction 0.3. Then calculate its acceleration. So force is not given, just mentioned force is applied. Here the data is given only coefficient of static friction, and you are asked to calculate acceleration. Now see here, the block is on a ground surface. The block is experiencing these number of forces. One is applied force F towards right side, so frictional force is left side. There is a normal force in the upward direction, weight of the body downward direction. So by seeing normal force and mg, we can get into conclusion that normal is equal to weight of the body mg. So I can write normal n equals to weight mg. Okay, now but according to the frictional force formula, frictional force F equals to mu s n. Mu s, okay, instead of mu s I am writing u symbol into n. but which is equals to u into mg. And see this problem carefully. I said that it's just started motion. Just started motion, this applied force is equals to frictional force. So that's the frictional force equal to applied force equal to frictional force. So we can write that F equals to capital F, which is equals to m into a, according to Newton's second law. So with the second line and third line equations, we can get into conclusion that u into mg equals to m into a, and that gives the result where m and m's cancel, u into g, which is equal to a. It means acceleration, if you want to get, you will get by multiplying the coefficient of static friction with the acceleration due to gravity g. Now what is a equals to, what is coefficient of static friction? Coefficient of static friction is given 0.5 into g is 10. So the answer is 5 meters per second square. So the acceleration is 5 meters per second square. Okay, in the problem I mentioned coefficient of static friction is 0.3, but mistakenly I have written 0.5, but the answer is same. The method is correct. If it is 0.3, then just simple 0.3 into g is 10. We will get the answer 3 meters per second square. So this is how you can find the acceleration of the body. So here you should be informed that when you are given friction, and the acceleration doesn't depends upon the mass, because here the acceleration is mu into g. So acceleration depends upon small g, which is acceleration due to gravity, and mu, which is coefficient of static friction, but not on mass in this case. The second problem, a 1500 kg car is going around a curve with radius 25 meters. If the coefficient of friction between the car's tires and the road is 0.5, what is the maximum speed at which the car makes a turn? See the second problem diagram. There is a car taking a circular turn with the weight mg, normal force n. When the car taking a circular turn, there is a centripetal force acting on the car so that it shouldn't move away from its path. And here the centripetal force is developed by the friction, which is static friction. So we can write the static friction F is actually developing the centripetal force mv squared by r. But we know that the static friction F equals to mu s into, instead of mu s I have written u here, into n, capital N, which is equals to mu into mg. So the static friction F equal to mu mg, but static friction F developing the necessary centripetal force, which is mv square by r. So therefore I can write mv square by r equals to mu into mg. So if you simplify this, you will what the formula will get if you simplify this, because we need to calculate the amount of speed. So therefore v square equals to u into rg. This would be the formula. So this is the formula we have. V square equal to mu into rg. Okay, let me solve. Therefore v square equals to, what is coefficient of static friction is given to you, which is 0.5 into radius is 25 meters into g always 10. So v square equal to 0.5 into 25 into 10. So therefore v equals to V equals to, you will get 25 into 5, 125. So 125, which is square root, because square, if you take the square, the other side is square root. So square root of 125. So then if you simplify this, the answer would be equals to 11.18 meter per second. So remember this formula. When you want to find the speed of the car in a circular term without slipping, the formula is v square equal to mu s rg, and if you substitute, you get 11.18. The next problem: if the coefficient of friction between the typical tire and the particular highway surface is 0.85, what should be the minimum radius for the curve on this highway if the speed limit is 40 km/h? And the third problem, the speed is given 40 km/h, and you need to calculate the radius of the circular term. So same formula we use, v square equal to mu rg. R you need to find, that means you should know V, you should know coefficient of static friction, and you should know the G, and his speed we know, which is 40 km/h. So V equals to 40 km/h, but you need to convert into meters per seconds. So you need to multiply with 5 by 18, which you will get, if you simplify, you will get the answer 11.11 meters per second, that is speed. And the coefficient of static friction is given 0.85. So if you substitute the values here to find the radius, v square, which is 11.1111 square, equals to 0.85 into, you need to find R, into G is 10. Now if you simplify this, you will get the answer R equals to 14.52 meters. So this is also has the same method similar to the second question. The only thing is that in the second question they asked to find the speed, but in this question they asked to find the radius. So the answer is 14.52 meters per 14.52 meters. Thank you.